Oh. hello. Hello. Okay. I think what happened here is I'm actually dialed in on the phone, and I'm showing up as two different people here on Zoom. Okay. Yeah, hey guys, thanks for joining. This is Chris Fregly. I'm starting this sort of monthly PipelineIO community sync here. I've been super busy the last few months, and I haven't been able to connect with people as much as I want to. So I want at least 1 hour every month to get us all on the line and kind of discuss what's going on here. I think to start, because there are so many people, I think what we're going to do is I'm just going to go through some of the latest features that I've built. We've been putting together, me and the collaborators here for the past probably couple months now. There's going to be a lot of stuff this first call. I'm going to just remind you guys, if you do have specific issues, I'm posting this into the chat here to everyone, help@PipelineIO. This goes right to the ticket system. We all use Zendesk. This propagates throughout the globe, everyone keeping an eye on these things. I usually triage them, and if things are taking a little bit longer, I'll like dish it off to other people. But if there are specific issues, let's do it that way. Also, tomorrow I've got a bunch of calls with people. If you need to talk to me, shoot me an email, and I've got tomorrow wide open all day to speak to people. After tomorrow, I'm going to have to just go back to email and that kind of thing. So I'm going to be doing a bunch of traveling. Okay, real quick. So you guys can see the screen share, right? Everyone see the screen share. Okay, all right. So just going to pull up a browser here. And get rid of the Zoom stuff. First of all, documentation. Here we go. Docs.PipelineIO, freshly generated just a few minutes ago. You guys want to check this out? It's got a little getting started action. One big thing, well, actually two like big things I've been focused on the last month are GPU support. In case you guys don't know, I've been doing this workshop. Actually, I'll just link to it off the wiki here. Zoom in here. So this is the FluxCapacitor/Pipeline wiki. This is the open source stuff here. Over to the right are these workshops. So these are paid workshops because we're using GPUs for everything, and these GPUs are not cheap. So I cover them, you know, at various conferences and things like that. But for the 4-hour thing, I'd ask that you guys, if you're going to participate, chip in a little bit. So there's a fixed price for that. Also, I've been doing these O'Reilly 3-hour workshops as well too. We can't go into too much detail because of the time. So that's where we get into the other workshops here. But anyway, and also speaking at a bunch of conferences, I'll be in London next week, and I think I'm going to Malta too in a month or so. Australia for ICML in September, and yeah, so everything there is going to be off PipelineIO websites. I'm going to be consolidating all these links, but for now, you can see all these things here off of Meetup, pretty much my entire schedule and everything we're doing. I should mention we do have an awesome meetup coming up. This thing, it's the reinforcement learning, TensorFlow. We actually have a guy who used to work on TensorFlow, this guy Yaroslav. You've probably seen him if you've ever done any Googling around for some hardcore TensorFlow questions, especially GPUs. Yaroslav pretty much is the man that answers everything. So actually, one of my friends is dating him, and I kind of worked that angle used a little alcohol and got them to agree to come speak. So this is June 1st here in San Francisco. It's going to be hosted by, actually, I need to put the new address in here, but it's in San Francisco. It's going to be at tripping.com. I'll update. Also have my buddy Don Dini, data scientist over at AT&T. He's got some really cool stuff. And in the usual action-packed meetup slash mini conference that I'm known for here, I've got a fourth speaker, Francesco Mosconi. He's the Italian stallion. He's done a lot of good training workshop for us. I've been partnering with him. You'll see some of his training show up on this meetup as well. So he's actually going to be doing this pretty cool hands-on reinforcement learning sort of little mini workshop that is a precursor to his sort of larger weekend workshop on the same topic. So I'm excited about that because I actually haven't seen it yet. So yeah, but definitely be like looking out. And of course, we will record it. We're going to do at least the Zoom thing the same thing that we're doing here. Also iPhones and, you know, the usual. Someone will have Periscope, I'm sure. All right, so that's the latest there. Here's the documentation, a couple things. So I mentioned GPUs have been occupying. I spoke at the NVIDIA GPU Tech Conference last week, and I believe that video is posted, but we had 300 GPUs I spun up for the audience. I was fortunate enough to get the huge ballroom at the San Jose Convention Center, which kind of surprised me, but and I was able to follow one of the like TensorFlow Google guys speaking on TensorFlow. So I was able to get a lot of overflow from that. But we spun up 300 GPUs. We were all doing the workshop. We, you know, crammed a 4-hour workshop into 45 minutes and had a lot of fun with that. But there is an entire GPU section here, so you can check this out real quick. And it's got the Docker images and some talks and everything GPU related in the PipelineIO repo. All right. The other big thing I've been working on, so if you want to log in to PipelineIO here, we can just go to community. So this is the community edition, following the likes of my former employer, Databricks, and many other people before, where they come out with a community edition. And then, of course, very quickly, try to convert you over to paying customer. So check out the community edition here. I'm already logged in here, I think, but let me do it incognito to match what you guys have. It should ask you to log in. You can log in with Google. I think you have to sign up first, actually, but so this will get you in. Okay, and let me zoom in here. All right, so a couple things to show. Some of you may have seen this before, but some of it, and actually I'm going to pull up on the left here, I'm going to pull up the supported apps and tools. So some of you that have been following me that are currently using PipelineIO, the open source version, know that you can use Airflow and Cassandra and Elasticsearch and HDF. This is all supported out of the box. These are all hooked up to each other. Hystrix, which is the Netflix open source, that's for microservices and for fallbacks and things like that. That's what the prediction services use. Of course, Jupyter Hub, Kafka, we've got Kibana, got a bunch of dashboards. We've got the Hive Metastore. This is key for Presto and Spark and things like that. Of course, MySQL prediction. And so these next 6 are the prediction services, or 7. So we support native Java. If you just want to submit some sort of ad hoc Java code for your model, you can submit that. Of course, PMML. If you want to submit Python 3 code, just sort of ad hoc code. I've been getting a lot of people asking, hey, you know, I've got scikit-learn and I've got this and I got that, but I want to stitch them all together into an ensemble. How do I do this? And so we opened up just Python, just sort of ad hoc Python 3. You can do basically anything in there. And of course, scikit-learn, we support that natively now. You can upload a pickle file and then it gets deployed as a REST endpoint. I'm going to show some examples here in a couple minutes. Of course, we support Spark, TensorFlow, and TensorFlow-gpu. All of these pretty much support GPU if your models can take advantage of them. If you're using Numba, something like that, in the Python world, you're more than welcome to spin that up. We support Presto, we support Redis. We use Redis for recommendation serving, essentially loading up large key value pairs into Redis, distributed Redis cluster. Of course, Spark Worker. So this gives you the ability from within the Jupyter Notebook to actually scale up your Spark cluster on demand. You can say, yes, I'll show you guys the little command line interface. That's the other big thing I've been working on is GPU and CLI. So GPUs and command line interface. So Turbine's more, that's another dashboard that works with the circuit breakers and Netflix open source stuff. Weavescope. So Weavescope is a third-party open source tool that gives you insight into your Kubernetes cluster. One piece of feedback I took from the community is that that thing was wide open, and by default, people didn't realize this. Right, so outsiders can actually hop on in and take a look at your the cluster. I don't know of any known exploits, but it was, there's enough people that bothered where we made it internal. So I'll show you guys a way to proxy later on using Kubernetes port forwarding. It's actually built into the PIO CLI. Webhome is actually what's powering this right here, the screen on the right. And for those that still love Zeppelin, of course, we support Zeppelin. That's what I started off with. And then Zookeeper. Zookeeper is used heavily by Kafka. So, of course, and for any large-scale distributed, even for like TensorFlow distributed, we're going to be using Zookeeper when we start scaling out that side of things as well, too. All right, so if you click Jupyter here, on the right, you should be able to get into, here, just right now, just use any username and password here. I actually don't have this linked to the others, like login screen, so just use anything to kind of hop on in there. I literally just added security this morning, and I didn't get all the single sign-on stuff working, so. Click on files, you can kind of click around here if you want to look at some Spark stuff, scikit-learn models, things like that. So these demos right now are very PMML based. That's just because that's how we started, just to kind of get our feet wet and performance testing and making sure the model servers were stable. From the command line, I'm actually going to show you guys a lot more support than just PMML. So hold tight. All right, so let me make sure I cover everything we got here. Supported models. Back on the left for the documentation, I just want to point out all the model types that we support. You'll notice a lot of similar tools to PipelineIO companies like Bitfusion, things like that. Only support a couple of these. We support all of these. So we support TensorFlow, we support scikit-learn, of course we support SparkML, XGBoost, Deep Learning for J, R models, let's see, Redis key value recommendations, like I said, Cassandra-based key value recommendations, TensorFlow key value. Not many people know this, but TensorFlow serving actually has a key value store built into it as well, so we support that. Any sort of native Java, if you give us a snippet of code, we'll push it out to the model server, it'll compile on the fly, and boom, we're serving your custom Java code. I've seen the native Java used in cases where people need to connect to legacy prediction services that have REST endpoints. So they actually deploy a model to the PipelineIO model server that's using HTTP clients to call sort of internal model servers, and then they're in building ensembles on top of those results, right? So they'll take the data from the existing legacy system that they didn't want to rewrite. It had a nice REST API. They just want to get the results, and then from there, then they can ensemble average, do whatever they need to do from there. It's not the fastest. way to do it. You know, there's tricks and, you know, things, persistent connections, things like that, that we definitely have to play with when you go this route, but the support is there. We have native Python 3, so this is good for things like Numba, where you can get to the GPU. If you don't know, Numba is a drop-in replacement for NumPy that gives you access to GPU. Actually, on the right here, I don't think I added these samples yet. My most recent workshop, I actually just got back from the GPU Tech Conference, like I said last week, and I have a whole ton of more GPU Python, like Numba, like type examples that I'll be adding to this master set of examples here within Jupyter. Of course, we support native C++, PMML, and any kind of ensembling. It should just be a combination of all of the above. Okay. Let's see what else we got in terms of documentation. All right, so here's my favorite, CLI commands. So over the past month, I've been eating my own dog food here and working with some of the active like contributors. We've all been kind of comparing notes and figuring out what's the bare minimum that we need. We went from bare minimum to the utmost maximum things that we could jam into one CLI. So I'm gonna just quickly break down all that's involved, all that can be done with the PipelineIO CLI. As like a lot of you probably know, so PipelineIO is based on Kubernetes, which uses Docker and gives us the ability to scale across clouds. So not just within a cloud, but also federated clusters. So there's federated support within the PIO CLI. And you can actually join those with your on-premise clusters as well. So you can have this huge, like federated cluster, and which is highly scalable, highly fault tolerant. If you lose an entire cloud provider for whatever reason, you can actually shift traffic over to probably Amazon off of Google. Probably the other cool thing that we're working with one customer on right now is this auto shifting for cost savings. So, imagine you're working on you've deployed your serving models or doing your training on the Amazon cloud with your Spot instances, and then suddenly around 10 a.m. Pacific time, you lose all of your Spot instances because demand goes up. And now Google becomes cheaper, or maybe Azure becomes cheaper, or maybe it's just cheaper just to shift over to your on-premise cluster because you don't, yeah. And so what we do is actually auto shift all of that traffic, training traffic and serving traffic, over to the most cheapest option at the time. And so, at scale, there's quite a bit of cost savings there. And this is just a quick command line click away. Okay, so just real quick, here's some configuration things. So PipelineIO, similar to Kubernetes, has a .pio/config file. So let me pull that up here. Show you guys what I'm talking about. Okay, so upper right is where we're looking here. So let me kind of scroll down a little bit to make it. Okay, so clear. So to just to kind of show you guys, this is all YAML based. This is the PIO/config file, similar to the PIO or to the kube config file, just kind of following along that pattern. And inside here, it's just a bunch of configuration. So this is how you configure it. You do PIO and then call the init PIO commands. If we want to actually look at the config, we just do PIO config. Boom, shows us the exact same thing that's in there. Now, there's a few different aspects to the PIO CLI. Like I said, we kind of got crazy and started adding everything in here. So you can actually initialize a model. So let's say that we're going to work with a particular model for the next 30 minutes. Let's say we're going to work with the TensorFlow model. So I've actually already configured this. The model name is TensorFlow Linear, the model namespace. This is just kind of a logical grouping. I could call this model namespace C Fregly, for example. So But yeah, for right now, it's just default model server URL. So this is specific to TensorFlow. This actually has the TensorFlow runtime fully optimized, turned on all of the optimizations there, and model type is TensorFlow. So these are all the model specific. And so actually we can do, let's see, does this have model server, model, the model version, where's model version? Looks like model version isn't set here, so PIO. Let's just do a init-model. TensorFlow linear. Actually, let me get into the directory with TensorFlow linear. Zero. Okay, so here, actually, just to speed this up, I'm going to do config set model version 0. A slightly older version of the install PIO CLI. Let me get the latest version on here. What we're doing here is we're going to configure PIO to know what's going on. Hang on. Where the model is that we are going to currently be, and just as a convenience thing, we can configure it once and then actually start to work with it and not have to keep telling it where the model lives and all that stuff. So actually, I think I'm just going to go to my local here. That's the one I was working with before. All right, so let me just do PIO config real quick. Let's take a look. We've got the model path, everything, the model version. So let's change the model version to be, which model type is this? Oh, okay. Actually, this is the scikit one. So let me go to that one real quick. So the context here is that we're going to actually deploy a model and then start predicting against it with just a couple command line clicks. We can also do this from a REST API, which is outlined in some of those Jupyter notebooks, although they still need a bit of an overhaul. Okay, so PIO config. Let me just show you guys what's going on here. So there's the model name, scikit-learn linear. Namespace is default. That can be anything. It'll just, if you and your coworker are working on the same model, you would want to namespace it so that you can access the same model server for dev purposes, but keep things isolated. I'm just going to call this v3. Actually, let's bump it up. Let's say we're going to do, so model version PIO. Let me minimize that. Config. Oops, PIO. Let me see which version I have here. Set. Yep, PIO config set. Model version is v4. Okay, model type is scikit. What is the model server URL? Let me just update this because this should be be updated. Boom. It is going to be HTTP. We want the scikit specific runtime optimized for that. And let's see. PipelineIO. Hopefully that works. Okay. let's do this. Let's do PIO. We should just be able to say PIO deploy. This is going to tar up anything that's in there that's not inside of a PIO ignore file. It's going to push this out, hopefully. I might have changed the name of the server. It's like here. I think it might just be demo. Usually this comes back a lot quicker. Let me do PIO apps. These are all the apps that are running. The scikit one's not running. That's the problem. PIO start, prediction, scikit. And that's all we have to do. Starting app, boom. This is just saying that the service is already there. Just ignore that for now. We're going to be cleaning that up. If you want to see all of the apps that are available, that's that same list that you had seen before. We're always, we'll be adding tools as we find them useful and as people ask for them, but you just do PIO space apps, and then this shows you all of the apps that are currently running. So scikit should be running now. So let's try the, just set it back to the community one, and then let's try the PIO deploy. And we can take a look at the logs on that. Just a command, PIO logs. All right, so it looks like it's still actually coming up here. Still setting up the runtime for scikit. Setting up conda. Okay, now we should have it. Boom. Add the right URL. Okay, let me do one last. It just changes over to community from demo. Let's see if we get this. This isn't going, then we'll just keep moving on. Okay, there we go. So that actually did deploy, and now all we have to do is do PIO predict. And let me just show you something here. When we configured this initially, we actually specified a test input path. And so just kind of a convention, best practice here, we should have something in here called test inputs. Test inputs, and there's just an example feature. Let's see, which model is this again? This is the scikit. Yeah, this is just linear regression. So we should be able to go PIO predict now, and it's actually by default going to slurp in that test underscore inputs, and there's the output there. You can override it. You can actually tell it, test model test input path, right? And give it like a different set. You can also call predict many, just kind of a little mini load test here. We'll do PIO predict many 25, and it's just going to slam this thing 25 times. It's actually using multiple process within Python. The command line's all Python based, of course, and it's just going to slam it. And there we go. So let me do one more that's kind of cool here. We can do the TensorFlow one as well. Let me look at the configuration and do PIO init-model, and we want to change the model name to be TensorFlow linear. We want model type to be TensorFlow, and the endpoint model server URL to be prediction. We want the prediction TensorFlow runtime. Boom. And oh, I think I have to specify all these. Except the model test input path, test inputs, and what was the other one that's required here? Model namespace and model version. Okay, model namespace default. Model version is, let's say, 1. Okay, what else did I forget here? Model path. Okay, so now we've configured the important things here. We just switched to model name, TensorFlow linear, the TensorFlow runtime, the model type, test inputs. So everything should be good to go. We should just be able to, now that we've set it up, so now, we can PIO deploy. This lets us do rapid deployment, right? So now we could rapidly deploy. We can make little changes. We could rapidly deploy. And we do predict. It's going to slurp in those test inputs. And you can have, really, yes, more than one, of course, in here. And then, of course, the predict many, which I like, just kind of gives me a quick feel as to the performance here. Okay. So let's see, we're at about 9:30 here, so I want to leave room for questions. But yeah, the other ones that we've implemented, there's the Ad-Hoc Java. So let me just show you this one. So this would be some just kind of Ad-Hoc Java. This is a very simple model. You just have to implement this predict method that takes inputs, and it's going to return a generic object, which could be anything. So this particular model is just checking if the input coming in, input ID, or key with key of ID, if that value equals 21619, just return true. So, the test inputs, of course, looks like that. That's the JSON coming in, very simple. To show you guys. Oh yeah, this is the HTTP client. This is that one I was telling you earlier. You can actually connect to a third-party system and get a prediction and then use that. So this is just using HTTP client Fluent API there. Back here. So there's TensorFlow, there's scikit-learn. Here's some Ad-Hoc Python. This is kind of fun. You guys can check this out. 0 model.py. So this was contributed, actually a sample contributed by one of our users. So there's no scikit-learn or anything in here, so it's not very interesting from that standpoint, but it just kind of shows that you can deploy ad hoc. And as long as you implement this predict method that takes inputs and returns an output, we are good to go. The framework can support it. Last thing I'll show you here is scikit linear model PY. So here is a scikit-learn. So here's the model that we train. Looks like this is the diabetes data set. We save it out as a pickle file. Once that pickle file is saved, and as long as the pickle file supports this predict method, which it does, it's just deferring to the scikit-learn model beneath the covers. Here you can actually change this to the predict proba if you want the probabilities back. But as long as there is some like predict method and you can do whatever you want within there, then the framework can call it. And like I said, we have Spark support, just general PMML. RSport, that kind of thing, XGBoost. All right, so that's kind of the model side of things. That to me is pretty interesting stuff. So we threw everything in here. We have cluster creation. So for Kubernetes, we use this tool called kops. That's how you would actually initialize a cluster and then bring up a cluster. This is going to use the Amazon API or the Google API beneath the covers, depending on what you're doing. Let's see. And then once you actually have the cluster up, you can view the cluster. So PIO cluster, let's check out our cluster over here. And this is everything that's running is we have one master, we have 4 nodes. Right now we're just within Amazon, just to keep things simple. This is every service that's running. Here's all those prediction services, all those runtimes. We've got metrics. Everyone loves metrics. Actually, I'll show that here in a sec here. But yeah, let me keep going with the PIO CLI here. So you can look at all the clusters. You can join a federated cluster. You can look at just the nodes. You can look at what's called these instance groups. This is kind of a Kubernetes concept where you can logically group nodes together. For example, if they're all GPU nodes or something like that, or if they're all optimized for the inference and not necessarily for training, things like that. Volume, secrets, and maps, these are all Kubernetes concepts, things that you want to pay attention to. And my personal favorite, which I find myself using more than I would like, is PIO top. So top can actually tell me across my cluster, how are all of my nodes doing? So this is just a quick command line away. If I want to actually look at a specific app that's running, I can do top, just that app, and it's going to show me the app. It's also going to show the cluster just because we can. Also, we've written this CLI to be sort of friendly. So even if you get kind of close to the app name, this should still do it. So there. So I didn't specify the whole prediction dash TensorFlow. I just said, TensorFlow, and it still found it. So let me look at another example here. Would be, yeah, I could just say, yeah. Actually, I don't have Presto running here, but yes, so you guys get the idea there. Okay. Also, some of us use the term top in working with certain users that are not very opsy. They haven't heard the term top, so I tried to also use aliases for things that maybe are a bit more intuitive to non-ops-like people. And okay, so here's application management. You guys saw me start up the prediction scikit-learn runtime. You can also stop or kill. Let's do something fun. Let's actually do PIO scale. So this is where we can actually scale up either, something at training time, like a worker, like a Spark worker, or we can scale up prediction dash TensorFlow. And if I just do that, it's going to complain and say, hey, you have to actually give me the number of replicas. So I'm going to say prediction, I'm going to say, give me 5 of these. And I don't think I have my Spark cluster running, but I could do the same with the Spark worker as well. So now if I do PIO ops, it should tell me 1 of 5 are currently running right there. If I look at the cluster to get maybe a little bit more detailed view, I should be able to see the actual pods themselves. Yep. So if I run this again, I should actually see all 5 of them running. These 2 are taking their sweet time. They're coming up, but so you can scale up, you can scale down. You can actually do a rolling upgrade just by doing PIO upgrade. You can give it a new version. So if I've made a change to the TensorFlow implementation, maybe updated to TensorFlow 1.2 beta, something like that, I can do an upgrade, and if you just type it, it'll tell me what we're missing. You have to give it the app name, which would be prediction-TensorFlow. You give it the Docker image, give it the Docker tag, and it will actually roll that cluster that set of services and updates. If you mess something up, you can roll it back using PIO rollback, kind of fun. PIO canary, this will actually, instead of replacing like you would do with upgrade, you would actually do it a canary, give it the Docker image, the Docker tag. It will side by side, it'll keep the existing cluster if you have 5 nodes. It'll actually add another node. So now you'll have 6 nodes. That 6th one is actually running the newer version. And that now becomes part of the load balancer, and 1/6 of the traffic is now being sprayed to that new canary version. And so we're building some tooling and some metrics and dashboards to actually do the canary analysis. I've been working with the guys from Netflix. They're actually about to open source their big automated canary analysis tool. So we're trying to work with them to get those in here. If you want to look at logs let's say we want to look at the, again, we can just get anywhere close. Let's say we want to look at the scikit. So we don't even have to type prediction-scikit. And these are all of the warnings and things like that are happening. It's like someone's out there hitting it. It's kind of cool. So you can actually look at the live runtime. If you want to connect, or as us ops folks would say, show into a particular runtime, you can do the same. So let's say we want to go to the Java runtime, to the prediction runtime. Now we're actually on that box. We can actually top. We have to do term goes xterm, I believe. I always have problems with this top. Yeah, there we go. So now I'm actually in that box. I can look at all the logs. I can do more detailed debugging this way. So let's exit out of there. I mentioned before about Weave Scope. Weave Scope we've locked down, so it's not publicly available anymore. You have to actually, so here I'm on my local box. Actually, is Weave Scope even, let me start it up here. It's not Weave-scope-app. Should start it pretty quickly. Starting up. Okay, so just what we can do, and yeah, I would recommend this actually for pretty much everything you do. If you even want to run Jupyter Hub, not publicly exposed, I would definitely do it this way. And what you want to do is, so once that's running, make sure it's running, Weave Scope, it's taking its time. You would do PIO, I would call it tunneling maybe, or, proxying, I don't know. I just put them both in there, but tunnel. Yeah, you would say Weave Scope, and you would, if you don't give it any local port or any remote port, so what we're doing is we're creating a tunnel from my local machine to this Kubernetes pod, right? To this service. And now the only person, so I have to be and then I would go to localhost : something. So let's see if this will work here. Actually, looks like I have a typo in the CLI there. Need to fix that. But yeah, so that would actually return with, I could fix this real quick. The local host port that you need to connect to, and then that will then proxy over, and you would run it as if it's publicly available. What line number is that there? 976. Boom. Okay, this should be. All right, so it's saying if I go to this, so what happened was I didn't even tell it what port that Weave Scope is listening on. It was able to auto-discover that using the Kubernetes API. And now I should be able to go bottom right here. And well, I just say connection refused. I think it's still, might still be coming up. I don't know why it's taking so long. Yeah, it's still coming up, but at some point this is going to kick in and probably show up as we're talking here. And of course we can do, for a given app, we can actually look. There's also PIO flow, PIO submit. These are common terms that if you are familiar with Airflow and submitting an Airflow job or submitting Spark submit job, sort of convenience things you can do from the command line. So that's about it. It's been a busy month, as you can tell. We're going to continue evolving this. We're going to continue evolving the community edition, and some of the next steps are going to be model optimization. So here I've just been showing where we're deploying what you've built. For the non-community edition, for the paid edition here, so what we're going to support is you would upload it. We're then going to optimize the model. We're going to actually generate 3 or 4 different models. We're going to do some native code generation, change certain knobs that we can do, especially with TensorFlow serving, for example. There's some knobs we can change, and actually return you multiple URLs, right? And then you can then choose which one works best for your workload, right? And then you would tear down the other ones. And so we'll do some tricks to your model. So if you've seen any of my recent videos or talks on TensorFlow models and the graph transform tool, we can actually do some tweaks to your TensorFlow graphs to simplify things, to do certain operator fusing, yeah, so some of those tricks. So if you just give us the most raw model, the crappiest model that you can create, we'll actually take that and manipulate it in a few different ways, and then give you multiple endpoints, and then you can tell us which one is working for you best, and then we'll turn that on. The other thing too is Kafka support. So this REST API stuff's really fun and cute, but there's a lot of people out there that don't want to take the hit for REST. They have a Kafka stream, for example, or a Spark stream that they want to actually do the scoring. So yeah, that's obviously on the very short-term roadmap, because we have a couple customers piled up that are waiting for this. So hopefully by the end of the summer, we'll have that available, along with the canary analysis tools, along with A/B testing tools for these models, so that you can actually run experiments, sort of longer-lived experiments, and have the metrics and the dashboards to choose which ones are working. Of course, bandit testing, that's always been on the roadmap there. So yeah, there's a lot planned. And I had posted a link in the chat there, but I just went through and cleaned up all the issues and features that we've built. These are all the open ones. We would love contributions. We got 1,550 stars, 500 forks. Things are going pretty well. We've got a lot of cool projects in here. I mean, can't get to them all on our lonesome self. So anyone that wants to pick up any of these, please do. And there's a contribution guide, I think, here over in the contributing. Just basically create or find a GitHub issue that you want to work on, get it to work within PipelineIO community, and yeah, just send us the issue, send us your code, and make sure that we can reproduce it, all that kind of stuff. Let me double check to see if this leaf scope is still, yeah, leaf scope is still coming up here. I'm not sure what's going on. Okay, at this point we have about 10 minutes. I think, let me check. If you guys have questions, post them in there. I'm a bit hesitant to open it up to the phone because it's going to be chaos, but if you do have questions, throw them in there. How do I set up IPython Lab on Google Cloud? Yeah, of course. So I'm just showing Amazon because that's just what I happened to spin up the other day when I was testing out this PIO init cops CLI thing. But I typically actually do run on Google. I just it's good to go back and forth because each cloud provider has some tiny little differences, especially when it comes to Kubernetes. So you have to kind of keep an eye on those and make sure that we're always addressing those. So yeah, let me post a link in here. So here's the wiki. If you go to the sidebar, you'll see PipelineIO Community Cloud. And what you want to do is, if you're going to be on Google, just click on this Kubernetes on Google. And when you're done there, it'll guide you to actually go to step 2 back here. So the first step is to pull down this. So what I found was trying to support thousands of people in the community on, and yeah, everyone's laptop is different and configured differently, and different versions of G-Cloud, and so in order to not deal with that stuff, I ask that you start with this Docker image that I've created, and there's instructions here on how to pull this down and how to get going, and do all of your commands from here. So start with that, and then essentially follow these instructions, and these have been tested by many people. If you do find issues, shoot us a note at help@PipelineIO, and we'll get them fixed. We're very, very super responsive on these installation type things, because we know that this is what holds people up when you're trying out this platform. So here's instructions for Azure. From what I hear, these are pretty close. People that seem to know Azure know how to get around any of the little nuances that are slightly different. So feel pretty good about those instructions. If there are things we could tighten up, please let us know. Just shoot an email to help@PipelineIO, or create a GitHub issue, whatever you feel like doing. Also, we've got Minikube. If you guys know, there's this local version of Kubernetes that isn't totally up to date with Kubernetes. Not to put fear out there, but it follows very closely with Kubernetes itself, the full-fledged Kubernetes cluster, like Kubernetes. It's maintained by Google. It's just some of the more advanced features with like Kubernetes cluster. Some of them don't really apply to a local setup, but this is how you can get it going. So you can actually run most of the environment. You're bound by RAM, but I know a couple of people, even in just the past week or two, that have gotten this to work with the latest Minikube and follow these instructions. And then you would set up PipelineIO on Minikube. It's a bit crippled. Like, for example, I only have Jupyter Hub running because the second you start getting Spark and the Hive Meta Store and MySQL, now you've blown your RAM, and everything starts to fail, and it's a bad experience. So just know, if you want to get Jupyter Hub kind of working, that's cool here. But if you want to do anything serious, I would just follow the instructions for the cloud version. And what's cool too is that you can actually shut down. In fact, I think I have instructions here on how to shut down, stop the environment and then come back in and start it up again. And that has, I think it's on the specific cloud. So that you can save money that way. I think there's like stop instructions here, but anyway. Okay, any other questions? Please share the meetup detail. Here's the meetup. If you Google Advanced Spark and TensorFlow meetup, you should, and make sure it's the one in San Francisco. Actually, I have about 15 of them worldwide. They all kind of link to each other, but San Francisco is the main one, and that's where this is actually happening. Will be, I'm going to update this here in a bit. I think the person just sent me the address the other day, so I have to copy that in. But we're up to almost 7,000 people here. We're the third largest Spark meetup and #1 TensorFlow meetup in the world. So, any other questions? If not, you guys can, please join us in a month and let me know what's top on your minds and if you want to see anything done, and we'll prioritize it and get this going. So anyone that wants to set up a call with me, please get in touch with me today and we'll set up a call tomorrow. The best time will be tomorrow. Okay, guys. Thank you much.